So now we will try to understand how Wasserstein GAN paper generally computes the Wasserstein distance between two probability distributions. If we use the previous way, like we discussed in the previous tutorial, how to calculate the Wasserstein distance between two probability distributions, then we have to prepare a complete optimal transport plan, and that will make the entire training very tough or intractable. So in the current scenarios, the paper actually introduces two important concepts. First is Kantrovich-Rubinstein duality and one Lipschitz function. So with the help of Kantrovich-Rubinstein duality and by using the one Lipschitz function, the paper actually converts the computation of Wasserstein distance between P and Q into computation of supremum over one Lipschitz functions by maximizing the expectations between two probability distributions. So here, if PR represents the real and PG represents the generated images, distributions through the generated images, and PR represent the probability distributions through the real images, then we take the differences between both expectations and we try to maximize it. Now what is the role of one Lipschitz function? So one Lipschitz function says that difference between two fx which are adjacent to each other may be at most 1. Or in a simple way, we can say that fx is equal to x, and if we have a multiple cases, then we can say that fi minus fj will be less than or equal to I minus j for all I and j. Now, by considering this, how we can calculate the Wasserstein distance. So now, just to take the probability distributions P. So in that case, expectations for probability distributions can be computed by using the probability at event probability. So now for that, we will use the non-zero based indexing. So first position, second, third, fourth, fifth. So at the position 1, the value is 0.5. So it will be at position 1. At the position 2, the value is 0.6. And for rest of the places, the value is 0. So it will be like 0 plus 0 plus 0. So by using this, we can say that the expectations value will be so it will be like that. And similarly for Q, the last two positions like 4th and 5th positions contains the non-zero value. So first 3 will be 0 and 0.5 into F4 plus 0.5 into F5. So based on that, it will be like 0 plus so the difference between the expected value will be like 4.5 minus 1.6, which will be again equal to 2.9. So that will be the that will be the Wasserstein distance between two probability distributions. Now again, you may ask some questions like if some functions may come under Lipschitz constant, one Lipschitz function or not. Suppose if we have a function like fr tends to real and we defined fx as 2x. Suppose we define it like that. Then for any point, real points like suppose x1 and x2, that is a member of R, then fx1 minus fx2 will be equal to, due to this 2x1 minus 2x2, that will be equal to 2 into x1 minus x2. Here k greater than 2, so that will be not one Lipschitz function, because the distance between two adjacent positions may be at most 1. So this is the general definitions. This is the general way, very general way, looks like a little heuristic way to achieve to calculate the Wasserstein distance between two probability distributions. So in the actual paper, actually to support the Wasserstein GAN computations, to suppose the Wasserstein distance based computations, and to avoid the chances of overfitting, the main paper had used gradient clipping, but some other paper claims that gradient clipping generally results in overfitting scenarios. So they came up with some gradient penalty based system. So but in the next part of this tutorial, we will try to discuss how we can prepare write a code for Wasserstein GAN architecture